What if the secret to our future is not just in the stars, but right under our fingernails?
It's like we need to witness these things. We need to let them be. And that's been a huge part of the problem.
We are going deep, from teaching permaculture to the next generation to unlocking the microscopic mysteries of the soil food web. It is time to move beyond sustainable and start regenerating. Matt, welcome to the show. What was the specific aha moment, I guess, that moved you from a high school teacher to a global permaculture advocate? What would you say, man?
Well, okay, so there was like a convergence of all these things. I had reached like the top of the mountain, so to speak, in my profession. I was teaching teachers. I had a master's degree. I was head of the English department. Everyone above me, or everyone who was making more money than me, was switching to admin. And I'm like, I don't want to be admin. But then I started like looking at like the realities of my situation financially. And I was like, I'm still in the same garage, my wife's grandfather's garage. And I'm still in debt, and it only seems to be getting worse because we went into medical debt. At certain points, we bought food with that. Don't ever do that, right? And I realized I was screwed. And so I was like, you need to figure out, and at this point, it was several years after I'd been in all those bands. And so I didn't see a clear path to making money in music. And so I literally felt this panic. And so I didn't know what to do. I knew I had to do something else. And then the first thing was like, I'm going to do permaculture like more, and I'm going to get good at it so that people want me to teach them. And I'm a teacher, so I could do this. And I also need cheaper food. And I've gotten notoriety like in town around this because people like hated the idea that someone was successfully like growing food up there because they couldn't. So I was growing 140-degree soils, water it, goes down to 120, add mulch, you can drop it to like upper 70s. It's pretty crazy what mulch can do. And so like I just applied the common sense of natural principles that permaculture provided, and I saw huge responses. And then I took Jeff Lawton's course. I asked to turn it into a curriculum, and he said yes, as long as he got to turn it into Arabic and then use it in his PDCs, and he did. In fact, for many years, maybe even currently, I don't know how many have sold. Well, no. You've sold more than that. But he initially printed 3,000 of them, and I was like, there's more of it in Arabic than anything else. So he was a great encourager. Dr. Elaine Ingham was part of that. Rosemary Morrow was part of that. Neil Speckman was part of that. And so it really launched me. They all vetted what I did and helped promote it. And I made more money than I make an entire year, basically, like in a month. And so I quit my job, not initially because I felt weird. I didn't want to abandon the kids in the middle of the year. And so I finished the year out and then decided over the summer to quit. But it was like very hard for me because it was like stability, and I was also part of the community in such a fundamental way. So like that's when I really decided to go all in, was that summer. And then I failed. Like I literally was like, now we're going to do a school, and the school failed. And then I had this fail upward mentality, and I still hold that, but it's like something that I dove into at that moment in my life, and I created an online version of the school I envisioned, and it was 120 people signed up, and it was like I think $100, and that was like, we're gonna be okay. So yeah, no, a lot of the things in my life are like that. So permaculture gardening, when that came out, I had just left Baker Creek Heirloom Seeds, and there was this whole thing that happened. And at the same time, I had the landlord saying, we're going to spray glyphosate all around the house in 3 days unless you rent the land around you. And I was like, what kind of game is this? And so we moved out in 3 days, and I came up with a course and launched it.
That's great, man. No, that's great. And so that was kind of the springboard that put you on to to put you onto the scene. No, that's great. That really is. Let's hop into it. Permaculture for the people. Let's get into the next segment. Demystifying permaculture. Matt, you are famous for making permaculture accessible, right? To a wide scale of people, all types of people. Let us discuss the core ethics, right? Earth care, people care, fair share, in a way that resonates.
Future care for me. Keep going with the question, though.
Oh, yeah, no, in a way that resonates with a modern audience. So with our audience today that we have, talk to our audience about that.
Yeah, so I say future care, because who determines fair share, right? And then like return of surplus, Bill Mollison had in there for a minute. Oh dear, who determines that? How draconian is that? It's like, this is all like socialism, tyranny, Marxism, right? And so like, I am too much of an American for that.
Yeah.
I mean, like my dad is like so proud of that. We're like sons of the American Revolution. He's got like the actual certification and everything. So we're like really proud Americans. And so like, I hear those words and I'm triggered, because it's like, this means this to us, you know what I mean? And so it's like, it has to be neutral. Like, I'm a high school English teacher. Like, I know what neutral is. Like, the language there isn't neutral, and I'm a hybrid of a lot of different things. I come from a lot of different places. And so I want to honor the best of all those different arguments. You know what I mean? Because it's like, there's an actual core value hidden in everyone's philosophy and belief that if you actually address, and you can steer them properly. So I always wanted to get past rhetoric, past politics, because that infects high school.
Absolutely.
And
it infects everything.
People at a principle level, because I believe that if people understand the principles at work, and the cycles at work, that they'll make really good decisions. And so it's future care. And so care of the future, well, that's investment. That's good planning. That's monitoring. And that's community access, right? 'Cause it's overlapping with people care. So it's like, I'm decentralizing, I'm autonomy, I'm independence, because independence begets the ability for us to have actual voting power. Like, I believe in these things, economic, local economies. And so my version of permaculture has all that in there. And that's not always the case when people learn permaculture. And some people disliked me for it, and some people really liked me for it. But I reduced it also from that perspective down to K through 12, because I was a K through 12 sub before I became a high school teacher. And I made it so that it was visual, because it has to be visual, and then linking principles directly to action. Because micro to macro ideation to creation, you have to connect those things if you want people to actually take action. So the permaculture PDC was set up so that you make a map and I give you a certification. As a teacher, I'm like, you're rewarding the wrong stage. That's progressive. I want summative. So I want them to actually do it, take action, and like get to that stage where they're doing critical thinking, creation, novel application. And then I reward that, because they've actually owned the idea. They become like, they've actually proven that they actually understand what I taught them for the first time.
It's not just that they read a book, right? Or that they, in theory, like, I can do this, but they've actually put their hands on and got dirty and figured it out.
And that's great. And this is why my PDC is called an advanced PDC, and I require them to do the project and show evidence. And then they have a story. They're like, well, what's your project? And then they just share their story.
Well, and not only that, but what it does is it weeds out a lot of people that really want to learn and people that don't. And I hate to say it that way, but that's the reality. If you're willing to take the steps that it's going to take to receive that certification, or take those extra steps and get your hands dirty, and not just be like, oh, I want to be, have a certification here that I hold for permaculture. You know what I mean? That at the end of the day, now it's like, no, you know what? I did it and this is why. And, here's my papers to prove everything. That's cool.
Well, because then they actually get to own it. They get to own the win. And it's also proof that I did my job.
And it's so funny you say that too, because in 2008, like when we started, that's kind of how it all started with biologicals with us, right? Is like, I'm the one that did the research project that lasted all summer long to figure out if they worked or didn't. Are they bugs in a jug? Like, what are they? Like, we didn't know what they were.
Yeah.
In 2008, they're bringing biologicals to us and like, check this out, like, look at these. And we didn't even know what they were at the time.
Beautiful.
That's the reality of it, right? It's just going to help build soil and save fertilizer and do all these different things, but nobody really knew the whole scope of it back then. And then that's when I did that project that lasted literally all summer long. And I still have it to this day. It's 25 pages long, has testing, has all those things to prove to myself that it's like, yep, you know what, this stuff really is what it says it is.
That's the magic. If you go through the process of proving to yourself what's true in a hands-on, dirt under the fingernails way, no one can take it from you. It's yours. And there's a power to that. There's an ownership to that. There's a grittiness to like the education that like it is character building. And so for me, I only want that, because then with the community we build with people who are like that is so stellar. I am just blown away by my regenerative soil and regenerative soil microscopy community. They are they're innovating. They're taking the principles and then extrapolating further and further, because that's what it does. If I'm introducing natural principles and cycles, if I do it properly, I'm simply doing a picture frame. I'm the picture frame, and the picture is nature. And so it's endless what we can learn when we're interacting with a feedback loop of nature that's clear and understood.
That's cool. That's cool. Now let's take it to the student perspective. All right. Why is it vital to teach these exact concepts to K through 12 students? So to the younger generations, right? Like when they're coming up through K through 12, why is that important? Or vital, really?
It's so vital because it gives them the micro to macro original scientific method thinking that is actually currently absent from schools. They don't encourage scientific method thinking. They actually have a premeditated way they do everything. And it's disempowering. It's the schools and schooling based off of the Prussian system, championed by the Rockefellers and Ford and all these factory owners, created a uniform obedience model. And so what we need now, though, because we've gone so far into that, is actually the opposite. We need people who are talented generalists. So the Prussian schooling model, which was beloved by the Rockefellers and Fords and these other, tyrants of industry, we got this schooling model that favors obedience and regurgitation of information. We're leaving the information economy. Information is going to turn into what your music has turned into, which is a subscription. And so it's a faucet you turn off and on, and it's always running. And so information is switching to that. And the economy is changing. So today, this information economy is coming to an end, which means that you need the discernment to swim through, to know what's true and what's not. And it's shifting to a critical thinking and creative and, really a place where we work as a community to create new common sense through quorum sensing and verification. And that's why, so much of my work has shifted to that micro to macro verification proof that's personalized to you, because that is the truth that we all can hang our hat on. And so that's been really the metric for my permaculture work, as well as everything that I did in regenerative soil, and then regenerative soil microscopy and regenerative soil DNA. So the amazing thing about permaculture and regenerative soil is they're universal principles. So it doesn't matter if you're on a balcony or an indoor grow or like the rules are going to apply. And so you're going to find that, you know, caring for the earth, looking at the cycles, understanding your light patterns, understanding the season, understanding what belongs in your climate, or what kind of microclimate you can create in your indoor environment, or in a secluded place, or a sunny place, or a warm place in your system. And that understanding is, it's like it's the lens that allows us to be proper citizen scientists. It's the lens that allows us to be, that allows us to operate with the scientific method in our own daily lives. And so I think it's even more important for people in the city because it's not self-evident. Like when you're a country kid, like I raised my boys outside of Yosemite, there was like mountain lions that like tracked my son, but our dog kept him away. And so it's like we have a completely different understanding of the world around us when we actually can witness the way nature works and see these cycles and then when someone says, "Oh, this is a cycle," you go, "Yeah, of course it is. I've seen that there, and there." But for city folk, this information is even more important because they live a disembodied life. And so they need to be part of the body of the ecosystem, essentially. And when we are, that's when we get the best food. That's when we get people like eat pollen, eat the local pollen. What are you doing? Well, you're becoming part of the local ecosystem of cycling of information, nutrients, and specific things that become your resistance or really alignment. It's really alignment. So when we're in alignment with a local ecosystem, we get all these health benefits, but there's also all these cognitive benefits and these mental health benefits that come from this. For me, it's just humans living more naturally. So that's what I would say to the urban question.
Absolutely. Absolutely. Let's deep dive into regenerative soil now, the soil food web 2.0. You've done extensive work updating our understanding of the soil, I'd say up to this point. Will you explain the Rhizophagy cycle, how plants actually eat microbes, or do they?
Right, they totally do. And then there are microbes that withstand their barrage of attack and actually release nitrogen. And those are the ones we call biofertilizers. And like arbuscular mycorrhizal fungi too, right? That's a biofertilizer. It's bringing in phosphate. And so these microbes, what happened was Dr. James White replicated a study he saw two ladies doing in Australia, and he just went like deep. And then he really proved that, yeah, all these plants, they are literally consuming the microbes. And then without consuming microbes, they don't produce root hairs. So they have to eat microbes to produce root hairs. It creates ethylene that makes them lengthen. And then it releases the microbes back out that survive this process through the root tip of the root hair. And so these exudates, they're also translocating and selecting for the biology in the soil.
Absolutely.
So there's and this, we've at times we've given an inordinate amount of discretion and autonomy to plants because when that sun comes out, they can't control it. They're going to photosynthesize.
Yes.
So they're going to do exudation as both secretion and excretion. So they can't help it. This is why John Kemp says, when they are having poor photosynthesis and they're releasing simple sugars as exudates, they bring in pathogens because they can't help but release the exudates. Wet their pants. They can't hold it.
You got it.
And so every day starts over again. And what happens is all these things compound. So if they're not processing their sugars, those simple sugars compound and they start leaking them. Insects and pests and pathogens come. And so I was really fortunate to be a one-on-one student that I don't know anyone else who had this experience. So Elaine Ingham took the time to work with me one-on-one over these long email chains and then these long format conversations over phone and Zoom. And I got to ask a lot of questions that people in the classroom would never be able to ask because it was just me and her.
Mm-hmm.
And so I really a lot of the things that she said that were absolutist in some of the things, she's speaking from a very certain perspective. And so I was able to like translate for her for a while, like what she was saying to people. Like people were like, Elaine's so wrong about nitrogen fixation. And I'm like, no, she's talking about bradyrhizobia, not rhizobium. And it's like, and so I was like this kind of like interpreter for a while. And then because I became so prominent, all these people that were like, Elaine's wrong about this came to me. And so I got barraged with all this stuff that like, I'm like, well, obviously your results are good and you're using a ferment that I've been told is evil and bad. And so I was forced to have an open mind because I did DNA testing and saw that the dangerous, anaerobic microbes were actually in all the compost and were actually facultative, meaning they live in the Goldilocks zone between aerobic and anaerobic, which is actually where our soil is. Our soil is at the surface, it's aerobic, like where it's all dried out.
As you start to head down, though,
it's facultative.
Yeah, that's right.
And then hopefully it just stays facultative. It doesn't have an anaerobic layer, right?
That's right.
So I was really blessed with being educated one-on-one by Elaine. And
did she talk much about rhizophagy back then, or would you say that that's just a lot more recent with Dr. White?
Well, what happened was if you read these books, you'll find that she says that if there's microbes in your plant, that your plants are sick. So that understanding wasn't here. She wasn't looking at the roots with the microscope. So, and the reason Dr. James White is he's a mycologist. So what I realized when I put all this together was mycology folks were seeing and looking at different things. They have completely different discipline around the microscope, and their community is lit up. They're all verifying and they're all like trying to create open source things to help each other. And so I have this like ethic, very permacultural, right? But also extraordinarily scientific, because we're in a situation right now where the final bits of information I can't access, no one can access, because we actually have to make a transparent and collaborative database that allows us to see each other's actions, amounts, timing, and results from biology.
That almost sounds like the blockchain for you.
It's the time of the season, right?
You're verifying.
Right. And I feel like it's an imperative within the community. The reason blockchain's valued, the reason blockchain exists is because there's an imperative that's coming from the community for transparency, because what they've done with a lack of transparency is so messed up. And so it's dark, it's sad, it's depressing. I'm not going to get into it, but the reverse is also, let's cast light on the world. Let's shine light on the good things. And what happens is, in collaboration, when we do that, we see good, we see better, and we see best.
Yep.
And then we get to choose. And so this is going to cause viral shifts in agriculture, and it'll prove, Rocky Mountain BioAg. It'll prove Terraganics. It'll prove mycorrhizal fungi. It'll prove green cover crops. It'll prove out all of the work of the people doing real, legitimate, regenerative work. It'll expose all the crappy, oh, that's not mycorrhizal fungi. That's actually just rock dust they're selling, right? Oh, that's not that's not Rhodosodomonas palustris. That's just yeast. There's all this stuff happening right now because it's the Wild West, because we have no quorum sensing in these areas. If we have quorum sensing with good clarity, good protocols, then we'll see these things, we'll protect ourselves, and everyone is going to get better food, and the future is going to be healthier, because healthy soils are what creates healthy plants, which is what creates healthy animals and people. And that truth, we know the reverse is 100% true, because it's like you get a pathogenic E. coli, it'll go all the way through and kill a kid. And it's the thing that people don't realize is the lettuce made it to market because it looked good. So these are not plant pathogens, they're human pathogens. And it comes from management, comes from a lack of biological controls, and it comes from, neighbors. and water contamination and other things that are off-site.
Not healthy soils, not healthy systems, man.
Yeah.
Right. I mean, that's what it all comes down to at the end of the day. Well, and that's where it kind of comes back to this too, like with microscopy, and citizen science. Apologize. Why should that? Yeah, man, I tell you, you have different languages even, right?
Yeah, there's times where I'm like, I'm not going to pronounce that.
Yeah, I know. And it's just simply microscopy, right?
No, I'm talking some of these like Latin names in like the Spore Atlas. You know
Absolutely.
what I mean? It's like Merospores, like that's pretty good, but Dothadias, that's not so bad. But Sphaeria.
Yeah, I tell you, man, I tell you. But anyways, why should the average gardener or farmer care about what's under the microscope? That's really what the bottom line comes down to, right? Why do they care, or why should they?
So the thing is, microscopy is much easier than you think. Microscopy is the way that you check on your soils and monitor it, because the microbes are the canaries in the coal mine. They're the thing that reacts first. And the environment determines their morphology. So you don't even need to be DNA testing. When things switch over, there's a behavioral difference in anaerobic conditions. There's also forms that are immediate tells. And then there's spores. So I just showed you a spore atlas. You just look up the color and the shape. And they're organized by color and shape. It's not actually hard. It's having the resources and the understanding of what to do and where to look and what to trust, And the thing that's crazy is it's like, it didn't say soil spores, did it? No. All the soil stuff is mixed up into everything. And so we have to have a database to help folks. But starting off, you can tell all these things. I can teach this. If your soil is just bacteria, you're going to immediately see that. If your soil is hypercompacted, even when it's diluted, you're going to see that. And you need your soil to have structure. You need your soil to have organic matter. You can see your organic matter. You can see actual quality of it in comparison to others. So the microscope allows you to get an understanding, because it's not that far. Like the thing is, everyone's like, oh, it's microscopic. It's like, it's not that much deeper. Like you can be looking at a root, a tiny thin root, and you're at like, 100x or 400x. And that's as deep as you're going to look at bacteria. So you can physically see that root. You're just looking like just a little bit closer than your eye can. And so it's like we're making small things bigger is all we're really doing. And those small things are the things that react first and then mutate into a form that is going, warning, warning, or it simplifies and things disappear and you're like, where is my nematodes? This gives you a really, really keen understanding. And then also, if you're growing things and there's no fungi, and you're growing things and there's no fungi, and you've added fungi, you're adding fungal compost that has fungi in it, you add it, and then a month later, 2 months later, it's all gone. You need to know why, because you might have residues from the prior owner, prior renter, the people who prepare the land. Glyphosate can last over 20 years in the soil. So, and like, regardless of what the internet says, regardless of what like the White House says, like glyphosate is terrifyingly bad for health, and it gets into the food. And so, and the byproducts, the downgraded byproducts can get in the food as well. In some cases, they're more dangerous. And so it's like, we need to look, and it's not just microscopy. Like, watch this. Okay. I did the microscopy on the compost. It looks amazing. It's the best compost there ever was, according to the Soil Food Web and Elaine Ingham. And I love Elaine Ingham. I'm just saying, like, you got all those pieces. That's step one. Okay. That's good. Now, what's your pH? Because if you did the Elaine Ingham method, it's pH 8. And if you're pH 7.5 and you're doing a garden and you're going to add a heavy amount of compost, you just locked up everything. And you just slammed everything with nitrates. And it's going to look good at first, but it's a trick. you're going to have like all this green growth, this rapid growth, and then you're going to have like fungal pathogens and blights and then pests and all this stuff. You're going to be like, what happened? It was, we were going so well.
You thought.
It's
You
a
thought.
yeah, it's a false, yeah, it's a misleading thing because nitrates are going to make your cells giant. They're going to require 4 times as much water. So, if you got water issues, well, what are we doing here? So it's a deep form of common sense when you can combine just looking at it, a microscope, because it's just common sense. We're going to make small things big, and then you're going to do more than microscopy with me. And you're going to look at pH. You're going to look at your nitrate levels. You're going to look at phosphates, because if the phosphates are high, and remember, NPK can be high in compost because there are macronutrients in plants. So of course they're going to be there. Like folks don't like put this together immediately because of the way we all got into it. We just got told compost is compost and compost is great. Just like we need more fungal compost. We need more. There's fungal pathogens, I'm sorry, that pass through compost and our saprophytes too. So it's not so cut and dry. And these things are simple though. You could be looking at your compost. You could see the banana shape with the segments, banana shape with segments. That's Fusarium. That's terrible. That's terrible. So farmers can be doing this, gardeners can be doing this, and it's a peace of mind because, and then it's also, do you know when these things hit, these late season blights and everything, they land like they're actually endophytes and pathogens, but they're plant pathogens, and the aflatoxins and mycotoxins from them are harmful to us, and they are in the plant too. But what happens is like that late season blight hits often when you're trying to dry down your seeds. So if you're a seed saver and a gardener, you want to make sure your soils don't have these endophytic, saprophytic pathogens, because when the sugars stop and you're trying to dry down your corn, you're trying to dry down your corn, meaning you're giving it less water. It's now giving less sugar to the microbes inside it. The Fusarium knows exactly what time it is and goes, oh, I'm going to kill you now.
Yep.
Yeah. And
it's time to grow.
It's
time to grow. And that's why it's important. Yes, but that's why it's so important that people need to know, gardeners, farmers, if you have the capability of doing it, which you do, right? Its question is do you have the time? And then like the courses you're talking about, do you want to get your fingers dirty? Like, do you want to get your hands dirty and actually go through with all of the work that it takes, like with what you're talking about, right? And so that's why it's so important, though, is because you can recognize these things happening ahead of time and know your plan of action. You're not just guessing then like, oh, what happened again and again and again. So, and that's what the next part of this is like, really, that's why it empowers individuals, correct, to test their own biology rather than, just relying on, say, soil tests coming from laboratories, right? Like this is forcing you to start doing some of your own testing at your farm, at your garden,
how long
those types of things. And that's how your work empowers those people to do that.
How long do those tests take? Are they flying through the air? Like, are they getting heated up? Are they like, there's so many factors to this. When you just take a soil sample, then this is the Elaine Ingham common sense. Her big thing was like, let's just take the soil or compost, put it with water and look at it. And it's like the immediacy of that is also so critical because you see what's really happening. And what they were doing in universities, they're baking the soil. So they're shrinking the microbes. And then the microbes are so small, they go past, literally are going past the ability for this to see. So the 60 to 70% of the microbes, the bacteria, you often cannot see with a light microscope. And so they're baking it, making it all disappear. And then they're like, this Elaine Ingham lady's crazy because we can't see anything because they baked it. So we have to be like really aware of the way they do things. And then if you're like doing an M3 test or regular university mineral test, that's just what's soluble. Microbes make things that are insoluble, soluble. So it's not like a true test of what's actually available. You need to do total digestion. You need to do the M3 or the Albrecht, whatever you want, and then plant sap analysis. And then you get to see like what's actually going there. And then you fill in the gaps with the different microbes. So home gardeners can make food that they actually can rely upon nutritionally with this process. because increasingly we're having these pathogens get into our food, get into the process of making our food. And, you know, garden foods is always going to be like our best food. But we literally can make it nutrient dense. A huge part of like John Jevons, like, you know, his whole like intensive growing was all this mineral adding because he was hyper paranoid because he would like test the original way that people were doing organic gardening and the food didn't have the nutrient density to support life. So it's like if we really are homesteaders, if we really are preppers, if we really want to make what's truly verifiably better food, you know, this is a this is a plant sap analysis. You can verify the food is actually better and nutritious. That's what you actually want. That's actually the goal of the home gardener, you know, and they want their seeds. They don't want to pass pathogen season to season, and they want to verify nutrient density. Microscope is part of all that. It's not the only component. And so I don't teach it in isolation. I do a little bacterial test with a microbiometer because that's fast and has the biomass. And that's critically important. Most people are like, oh, most people with a microscope that have been trained by Elaine Ingham are counting. And then they have to do a mathematical equation that scales it up to the acre. And if you've ever heard about this metaphor with a plane, if you start off and you're 5 degrees off with your calculation or a boat, you're going to end up
it's a long ways,
you know, over or in the middle of the ocean.
Yeah.
And that's exactly what's happening when they take that original number that they counted and then do this, because there's a rate of error because you can't see all the bacteria. So there has to be like a level of humility in our approach that Dr. James White is really the reason, full credit. His non-definitive approach, I would be like, well, what fungi is this? And he would be like, well, Matthew, let's look at the full life cycle and then we'll discover it together. And I'm like, okay, all right, full life cycle. Then we're like going through the full life cycle together. And he's like, well, you know, it could be this, it could be that. You know, and he goes through it so non-definitive. And I'm looking up these things and I'm like, oh yeah, I see what he's saying. And it's because in nature, environment drives morphology. Environment drives the way things look and are shaped. Why do fish all have fins? Why do birds have wings? Why do we have eyes? And the animals have eyes too. It's because it's a convergence of morphology in response to the environment and the challenges that are also, and food sources that are shared by us in that environment. And so when we gain this understanding and this fluency for this space, it becomes very easy to do. And you begin, what I found is, and I don't know if this is like off base, but because we all started off microscopically, like all of us started off, you know, sperm and an egg. It was microscopic. We all started off there. There's something about the microscopic world that has this deep call and allure and something about it. And I don't know. But that's what we, you know, when we return to the soil, that's what's going to happen. We're going to return to that. And so there's this deep interest, and people that get into this, some people they're not even growers, and they start doing the microscopy and they get so into it, they start gardening. And they weren't growing food. They just were intrigued by the space and what it means, because it affects everything.
But what's going to happen is then you get these gardeners that are interested in the soil, the why behind it. That's where nutrient dense foods come from.
Oh yeah.
You know what I mean? Like that's where it all starts, is really somebody looking at the why and then saying, wow. And then this what comes from it. So that's great. And then that kind of also talks about, you know, like as we move into this, and that's what you say, it's, you know, it's basically one tool. Like the microscope is one tool in the tool bag, right? Like you have to have multiple tools in order to fill out your tool bag to be able to really see. But when we get down to it, you know, like let's just look at the fungi versus bacteria. Let us discuss the importance of fungal dominated soils for carbon sequestration and plant health.
So this is the thing. When Christine Jones and Elaine Ingham started talking about fungi, they weren't talking about I mean, Christine Jones was mixing a mycorrhizal fungi into that. Elaine Ingham wasn't, because it was compost. Mycorrhizal fungi burns up in hot compost, so she wasn't talking about that. And you can have pathogens in there, and the saprophytes in there, and so when we talk about fungally dominant soil, we got to break that up, because we need the mycorrhizal fungi that partners with over 90% of plants bioregionally to be present everywhere. And that is a root partnership and a symbiotic partnership with the plant that travels from root fragment to root fragment year to year. And that relationship needs to be there. It's not about being dominant, like when she's talking about the ratios. It's about the plants being complete. So it's kind of a different paradigm, a different kind of story than was being told. And so what I say, all these mycorrhizal benefits, all this unbelievable things they do, those are just normal plants. They're just normal plants. We just gave them back their gut biome. That's all we did.
Exactly. And they're just doing what they do. Right. I mean, that's the reality of it, right?
And so most of what
but so complex
to do it when we
right. That's what's so funny.
Are the facilitators and let the microbes do it. It's infinitely complex. But our job and role and the way nature works, and is so forgiving. It's like, if there's certain processes that didn't work the way they worked, we'd be screwed. Like organic matter, like pushes us towards pH 7. It's like, okay, thank you. Like, holy cow, we're lucky.
Right. Just add organic matter, right? Unless you have high pH soils. And then what, right?
Yeah.
With no organic matter.
So I think that it's incredibly imperative to introduce people to the way that things work, so that they can create an understanding and build that relationship.
The importance of the fungal dominated soils for carbon sequestration. For the carbon sequestration.
Oh yeah. I can go deeper on that. So mycorrhizal fungi is the one predominantly responsible for carbon sequestration, because they're the ones that are releasing all that carbon and guiding the release of that carbon into the soil from the roots, and creating lipids, which is like the longest term, it's fat, longest term like storage unit in the soil. So this is part of the reason why these things stick, right? There's bacterial glues, but then there's glomalin and then lipids that are being released by mycorrhizal fungi. So mycorrhizal fungi is the actual thing. This microscope is the way you check for that. And so we killed mycorrhizal fungi in our soil by using phosphate, and the signaling to the plant, you don't need to give sugars to mycorrhizal fungi. So even if this germinated, it wouldn't get the sugars and it would die. The spores, well, they use desiccants, right? I mean, that's what nitrogen does to the soil. It desiccates it. Synthetic nitrogen is extraordinarily lonely. So it robs from the humus. It breaks down the soil organic matter, which is the structure of the soil. And then things leach away and then get slurped up by the plant. So we're burning away those roots. It was once advertised that synthetic nitrogen burns away the roots from last year to clean the soil. That's your mycorrhizal fungi they just got rid of. And then they guaranteed that they can sell you phosphate the next year. So, the majority of the world's phosphate that's inside plants currently is theorized to have all come from, majority or all. They can't prove it, but mycorrhizal fungi is credited with that. So it is the primary mechanism that phosphate was delivered to plants in the wild. How are they getting it? Right? It's nitrogen fixation from microbes. It's mycorrhizal fungi. It's these microbes, the only way that nature works. And so this is the only way that we can portably go and verify mycorrhizal fungi and its effects. So I can, you could do methylene blue, but you stain the whole root and then it doesn't show the phosphate glow. The phosphate glow shows how efficacious it is. So we can see hyphae, we can see this, but if it's a part of the root right here that's glowing and stuff, and you don't see this whole thing glowing, it's not efficacious, right? So this is a way that a farmer can also do it once. Check 2 to 3 weeks in on their seedlings. It's all the seedlings are glowing green. They're glowing green. And then the next year, they don't use an inoculant. They plant seed and they see it growing green. Now it's regenerative. So this is this is my protocol, right? And it's based off of what they did in universities with these giant microscopes for doing analysis on these things for writing papers. No one's used this in a commercial way yet. Not even mycorrhizal fungi companies have really dived into this, and they're realizing now because they can show their trials really well now. So this microscope allows us for the first time to bring back that symbiotic relationship with the mycorrhizal fungi all over the world. And that means that we can get rid of almost all phosphate fertilizer. And I'm a pragmatist, and so you could use endophytes like EM1, or what that is yeast, lactic acid bacteria, purple bacteria. Other people sell those same things. But the Terraganics, EMRO, the people that created it originally. So you could be adding those things, then reducing your urea by 50% right now, like this season, folks, immediately. And then they did that in Arizona, it removed the salt line in the soil in Arizona in one season, in 2 months. And then it increased soil organic matter by 0.5% in 2 months in Arizona. And they didn't stop doing the regular regimen. They just lessened it. So we can do this transition in a way that you don't need to be totally extreme and risk everything in your mind. We know a pathway through that is profitable. And also not immediately shifting over and maybe causing a problem, because the plants are accustomed to that. But it is with this system that allows you to see things early on. You can vet things early on. You vet the inputs as it comes through, like your compost that you're buying. If you are a farmer, oh dear, check that stuff. If you're a gardener and you're buying anything from a store, please check that. And if it's bad, return it and don't put it in your garden. Or I can teach you how to fix it if it's within a certain level. I mean, if it's full of microplastics, just send that thing back, because we can take microplastics with us as well. So home gardeners, microplastics, mycorrhizal fungi, all these different important aspects you've never been able to get before. But that's what my book, Mycorrhizal Regenerative Soil Microscopy, and my course is all about, covering those gaps and connecting these worlds that we're so separated, and then giving people the common sense, the critical thinking to go further than me. And that's what the database is really about.
Sure. Well, and that's what's going to help too, and that's where all of these things start to happen. And that's the holistic health portion of it, right? Because that community that you're talking about is a link between, soil health, plant nutrient density. It is also a link between all those things, because everybody's going to bounce those things off of each other, correct? At the end of the day, in a community, and it's the same thing. We have some courses as well, and it's the same principle in those courses, right? Because you start getting, like you said, almost citizen scientists or whatever you want to look at, and they start pushing that bar further and further. And then you can start linking
go
these
micro to
things
macro.
together.
And so the gardeners and small market farmers are research and development for the whole community. Then these large farmers are research and development, how to make that actually work at scale, which is actually very difficult for some of these things. I mean, the early on nightmares where people were like, I'm doing soil food web. And then they did compost tea in their drip lines and ruined millions of dollars of drip line because they gummed it up, and they didn't know they could follow it with EM and clean the lines. It's hindsight, right? So this is proven, and these are meat sticks. This is Ryan Noss. Ryan Noss is a soil consultant, soil ambassador. He was a student of mine in Introduction to Regenerative Soil Microscopy, and he's doing amazing things. We're going to be teaching a in-person practical practicum course together at some point. He works with farmers that are sometimes 500,000 acres, right? So he's there commercially doing all these things. He's going in with tankers with like just Elevate Ag, all these folks are all working together in this amazing, very regenerative community. And I'm just very blessed that they all have invite me in and include me in all that. But they prove that there's um, specific amino acids in this that are not present in all the conventional meat, and they're linked to longevity. And what that means, and they actually linked it to a specific fungi in the soil. So a specific fungi in the soil that's absent unless you're regenerative and have that. So it's regenerative and having evidence of this fungi is linked to amino acids in this meat. Now, if it doesn't exist in any meat that's standard, my whole life I've never had it unless I've had in the times I've had wild meat. So in other words, all those hunters were super onto something, but it also means that we're missing the building blocks for the proper proteins for our bodies. And we have been missing, and this is why we have autoimmune disease, I believe, and in a way we wouldn't, given the burdens of all the toxins we have, right? I don't think we would have the same concentrate. I mean, all right, my boys look at their grandparents and their great grandparents and be like, so they had mercury and that, and then they were like World War II, and then they ate that, and then they smoked since they were like 11. How do they not get cancer? Like it defies all sense, but I think it's because the food was just so different. Because they couldn't do it any other way. They had to do it the right way because there's none of these.
Absolutely. And they cared about trace minerals in the soil. They cared about so many. They cared, and maybe they didn't care about it even. They just that's the way that it was, right? Back then, they grew in good soils, right? Like over years, if we've mined them, we've mined them, and nobody realized there's a problem until the food supply starts to collapse. And people realize it. Like people have been blowing the whistle for a long time, right? But it's slowly starting to happen. It's slowly starting to come down, and and that's the hard part. I don't know. It's things are starting to head in the right direction though, and that's the good part. Quicker at a much faster pace.
It's kind of like change is happening because we're in pain. And most of us who have had medical things or espoused the medical things, we're here because of a health struggle, and that's essentially pain, right? And so that's, John Kemp, all these people have a story that relates around health, and that's why there's such an imperative and demand right now in our culture, because we don't have it. Because someone turned it into a game to make us unhealthy, to make money from that. And this is why people trust alternative medicine more. People, go to other countries, and some of these countries, they never had health care. And so government and then real deep, big corporations never had their hands on it. So their medicine is actually still intact. And so people are doing, different like ancient Chinese medicine and all these kinds of things because they actually still work.
The future of citizen science and DNA, right? And you said you don't have to have DNA earlier, but breaking the barriers. So you're currently working on making DNA sequencing of soil more accessible, correct? So explain why knowing the exact species in our soil changes the game. So if we know the exact species, what does that change, Matt?
So a few different things. We need DNA testing at certain critical junctures in our ag systems. We need to be having screening for pathogenic E. coli because, as I mentioned, it goes through, there's strains that go through hot composting, which on its own is concerning. And then we have it going into plants and the plants looking good enough to bring to market. So we can't see the difference between E. coli that's pathogenic and non-pathogenic. The conditions create that. So I can put E. coli in an anaerobic condition, and then it'll create pathogens, and it'll turn into a pathogen and gain virulence or horizontal gene transfer. This has been well proven. Dozens of studies have shown this. They even have articles being like, horizontal gene transfer is faster than evolution. And what they mean by that is faster than reproduction. And so these things are reacting in real time. It's really profound. But so I can fix a problem with management and remove E. coli if I know it's there. But what happens with all these sad stories are, it's like, well, there was a feedlot up the road or upstream and it infected their well. And then they put it on the crops, and then they sold the crops. Got to sell them fresh while they're fresh. And so they had like unprocessed, water in there with the pathogenic E. coli. So, because I mean, like lettuce is mostly just water. And so we have to really be aware and honest with ourselves that like you can't see that difference. And early on when I got into this, some people on the internet were teaching that you could, and were like freaked out that I said you couldn't. But it's just it's crazy. It's like, this is a serious thing. Kids die. Like, let's be real. So those that like you need DNA for that. And that kind of quality control needs to be part of the commercial world and the ag world, because it keeps happening. Right. So that's plant sap analysis for pathogens. And it's also going to be what's going in the compost, but also the water from the well. And so it's not just soil. And that's the other thing, is it's like, I really try to give people holistic common sense and critical thinking, because often you got to zoom out and be like, your soil is great. Your plants have pathogens in them. They made people sick. It's in the water. It's in the drip line, and it could be as simple as like, oh, that drip line. Oh, well, we just rolled that out and that was just sitting in the sun and we didn't flush it, did we? There you go. And so it's like that kind of common sense is so critical. The DNA testing can really help us, but we can see a lot of the pathogenic shapes for other things that are in the ecosystem along with pathogenic bacteria. So you'll be able to be like, oh, this is really anaerobic. I mean, look at all these water-philic aquatic microbes. This soil, it shouldn't be all this. And so that gives you an idea that there's sitting water somewhere in your system. And you're like, I might have E. coli that is pathogenic. I need to test. And then you catch things, right? And so the microscope, again, is that canary in the coal mine checker. And so you get to like verify, is everything good? And behavior wise, there's also a movement difference. So like anaerobic is like shimmering. It's like a mob shimmering with like ferocity. And then you have like this different like movement when it's aerobic and facultative, and they like do like little pirouettes, and then they're going like this, but it doesn't create this shimmering conglomerate mat like a mob. So you can tell the difference between these things, and then it can clue you into doing a DNA test. So, and in fact, if you study mycorrhizal fungi, this is how they select a DNA test. So they use this light on here, this blue light, to look for the brightest glowing ones, and then they DNA test that to save money, because otherwise it would be worthless to test something that doesn't glow. So it's extremely useful in pairing with DNA testing, microscopy DNA testing. DNA testing, though, the thing that I am going to do with that, which is going to make some people happy and some people not so happy. DNA companies are probably not going to be as happy, but DNA is a river. So the Mississippi, you test it one day, it's in the middle of a drought. In the middle of a huge rain event right after the drought, all that runoff, it's going to test different. After they're doing all the spraying, like desiccating for the field, it's going to test different. All of these, but that's still the Mississippi River. That's DNA. DNA is a river, and it's always changing in response to the environment. Right. And so we have to take like all of it with grains of salt. And what happens is people are like, this is my DNA. I've got these solubilizers, so that means I have this much pounds per acre.
Yeah.
Maybe.
If it's good, hopefully, right?
Right. But
Yeah.
but that microbe is dependent upon all the other microbes. You know what I mean? Right. It's flat, right? And then it's management, it's conditions, and then the actual like brittleness or durability of the soil and resilience and reaction. So some people have their soil get wet and then like ciliates like come out, and then there's like and then some people's soil gets wet and that's delayed. And so there's like a resilience, and some people's soils like expand. And then it like just like expands, and like it's like not pooling or puddling water internally, it's just holding it because it had enough water to like it just expand. So I really value the microscope. I value DNA testing, but it's expensive. And then what are we testing? I would test the dead and the living all at once. And that's why there's like 40% that they can't identify, because it's fractions of fractions of DNA that literally can be eaten and then reused. So they're like inert. DNA can take up to millions of years to break down. If something's called organic matter, what's organic matter made of if not DNA? So DNA testing soil is actually incredibly important. It tells you the past. It tells you what's the potential. It tells you the predilections. It's very interesting, but it's a snapshot. And I am going to break a lot of myths with the DNA book. So I'm also wanting this certain amazing researcher, Stephen Russell, to keep going with what he's doing, because he's combining things to do whole genomic reads, and then he's like reducing the price extraordinarily fast so that he can do like hundreds of like tests all at once. Very incredible. Very incredible. But I'm just observing him right now and how he's reducing the price, because that's the thing that's going to allow people to do it. And because the thing is, it's like, okay, if you got an initial investment, that's great. But if you can just keep reusing it, that's one thing. But the way a lot of this works is it consumes a lot of money to just do regular tests. And if you
you got to go do another one.
Oh dear, you got to start.
You get to do another one from the get-go, and sometimes they take hours.
Yeah,
and hours and hours. Yeah.
So okay. All right. So hours is a problem because this is what they do, because they don't want to spend money. So, okay. When I did DNA testing of soil, I realized that like it doesn't stop reading.
And it's still,
so
there's
like
stuff
I'm
being
like
found.
12 hours in, and I'm like, and then I was like, and this is pre-AI. So I'm like looking at all the studies, and they're like, I got this many reads, and I'm like, I have the most reads out of a compost DNA testing ever. And then I'm like, let's keep going. Let's see how far. And then I'm deleting all the apps on the computer because it's filling up the whole computer. So I'm like dumping, and then making this larger and larger file. And then I go to figure out like everyone is literally reading it for a little bit and stopping because it costs too much money.
Data centers, huh? You got to have data centers in order to get it done.
Maybe, but I'm just like, just like a citizen scientist, not even thinking about like money. And so I'm like using a whole flow cell. That's like $900 to $1,200. Like I'm eating up the whole flow cell. They would never do that. So they do it for an hour, and then they're like, now let's rewipe flow cell and start again with another sample, because they want to save money. But they're not doing an honest read. It's not an honest read.
But they have to somehow be able, because that same DNA test may cost what, 20 grand. I mean, I'm just throwing a number out there. Who knows what the number is, right? Like to do a full.
No. So I almost filled up the flow cell. I went 23 hours and then I had no more room in the computer. So I had to stop it there, and it was still doing it. It was small, but still doing it. And so I was like, okay. And I realized fundamentally that DNA is a story of confidence, a story of being superior and knowing more than you do, rather than an honest story of this is a snapshot of a moving picture, and we are only looking at a section of the
Yeah,
snapshot.
because you're going to have cameras shoved in the ground and continuously recording because it's going to change every minute, buddy.
And then
what's it?
Well, what about testing the genes that are active? That's another DNA test. So there's different types of DNA test. The active genes, all the genes, whole genome.
It gets wild, man. It's deep. It gets deep if you really get into it, you know? And I think that's what you said is like, if you can figure out how to bring that price down, that's where you're going to get those massive databases built, you know? And that's kind of what it goes back to. So, you know, and I call it the database of life, but how will gathering all this data from regenerative sites globally help us fight climate change, do you think, in food insecurity? Do you think we're going to build these databases, Matt? Is that what you're thinking is going to happen? That we're going to build these massive databases of all of the genome of the soil, and then we'll know how to combat things? Like, what do you think?
It's the way that we're going to be able to protect things, because once we show that all these microbes have all this crazy form of expression and they're in the soil and constantly changing, the paradigms for GMOs doesn't make any sense. Fixed DNA? Huh? That's not how microbes work. So then everyone will realize that the DNA for the GMOs is changing as soon as it's in the soil, so they can't own it any longer. And that's the big secret they don't want. So I'm not into AI. This is human based. All of it is witness based. So it's about like documenting this stuff and getting people to just share their results. So it's letting it all just hang out. I'll just show what it is. And the reason this is going to help with food insecurity is because it exposes good, better, and best practices, exposes what's the cheapest, what saves the most money, time, and effort, which is what farmers want to know. So this is a way that we literally can help farmers break through, grow more food more affordably while growing their soil. And it'll be more nutrient dense at the same time as an indicator of success. So like that side of it. And then climate change. Climate change is something that was called once desertification and habitat loss. And they transformed it into something they could greenwash and turn into your fault, because your car isn't the reason that like it's desertifying. it's hysterically it'd be funny if it wasn't so effective of a propaganda that it has hurt and messed up so many people's minds. But it's not your car, it's not your daily lifestyle. What's going on is that we have destroyed our watersheds. We've destroyed the photosynthetic capacity of the earth. People talk about high CO2. Yeah, well, because you don't have any O2 production happening. So it's actually like someone standing on the hose and then having that balloon up and going, look, the water is going to kill us. And it's like, you cut down all the old growth forests and trees and you expect like oxygen to be magic? No. Oxygen is created through photosynthesis, which requires CO2. And if we stopped having CO2 production, within 20 years, all life on Earth would die. So you need 84 billion metric tons of CO2 cycling per year. That's why fungi does that. We do like, I think 30, and then like our cars do like 4 or 5. Like it's nothing. And then like mycorrhizal fungi takes in like 13 into the soil. And we're missing it from all those soils. So like in terms of like carbon, It's just we really need carbon to be back in our soil because that's the soil organic matter. That is actually where the energy is stored, where water is stored. That's how we increase our CEC and hold more nutrients. That's where all the life lives. That's what it all boils down to. You know what I mean? And so we do need carbon, but again, they've like greenwashed it and been like, the missing carbon is your fault. Meanwhile, it's like, hey, wait, aren't you Shell? Aren't you a oil company saying this about my, because the whole like carbon footprint was invented by an oil company to shift blame from them and their activities to us. So yeah, and then a huge majority of the carbon release every year is just us losing the carbon that was put back into the soil by the plants. And so we're like, corn draws down 400 times the atmospheric increase in carbon every single year into the soil. So the whole Midwest, if we didn't spray glyphosate, if we didn't desiccate the soil, if we actually did it regeneratively, could sequester tons and tons and tons of carbon and rebuild the soils like easily. So it's really management, and it's really a lack of understanding, a lack of information that is holding everything back. And that's why it's a propaganda war online. And it's like a lot of trust me, bro, and a lot of just like people being as adamant as possible to like push their points through. And that's why like I'm not attracted to that. That's childish behavior. But that's what most of the internet is, right? It's high school. It's childish behavior quite often. And so I want a database that just shows clearly what works and what doesn't and why, down to the biology and the minerals, so that farmers can make and gardeners can make and ranchers can make and landscapers and lawn care people can all make informed decisions that are strategic, that build soil, that build their bottom line, help them save money, help them make more money, help them have better products, which means they can compete in the market better, and then prove it and verify it so they can compete in the market better, make sure that they're actually doing what they intend to do, heal people through food, heal people through medicine, all those kinds of things. But it comes with transparency, with testing. It comes with having a database so that those things can be facilitated. So that's really what it's about. That doesn't work. People, they're like, oh no, that doesn't work. And that's why the database is so important, because it works. It's nature. We have people who aren't using NPK. We have people that aren't tilling any longer. We have people that don't use herbicides or pesticides. We have people very, very successfully erasing most of the overhead and then doing things that other people think is witchcraft, or doing nothing because they already did the work and now it's regenerative. And that again looks like, you're just blessed. It's just the way it is. But with these tests, with the ability to verify each of the cyclical components and steps along the way, we're going to be able to help people see and understand this and help it go viral. But I respect, the skepticism wholeheartedly, because you all have, like, if someone's asking you about this or interested or even looking in this direction, it's because they know that they've been duped. They know on some level that these fertilizer, herbicide salespeople that are selling them things that are harming the soil, because there can be people selling biofertilizer, and they're fertilizer people too, but they've been sold snake oil. They've lost money. They don't know who to trust a lot of the time. And it leaves them feeling like, I like you, but I don't know if it's real. I don't know if it really works for me. And that's why I just want the database, because it's not about me as an educator. It's not about, these ideas being associated with organic or regenerative. This is just the way nature works, and you can prove it to yourself, and you can save that money, or you can make a clean product, because we can prove that these things are dangerous too. So So I really believe like that's the kind of place to start with, because I really do respect all these farmers. They've been through it. Most of them are dealing with the sort of risk that people don't even comprehend. Like, it's not like they're like, I spent $100,000 on college. It's like, you don't even know what you're talking about. These people are millions of dollars into debt. And at the same time, they're trying to hang on to family their great grandfathers acquired, and it's now their responsibility to hold on to it. And it's intense. What they're trying to do with our country, trying to break up the ability for us to own land, pass it on, to withstand this slow crush where corporations or people like Bill Gates own everything. So I really respect farmers for having that reaction given the circumstances they are in. But that's the number one thing, because organic didn't work. And I know that's so controversial.
It's not, I mean, it is, but it's not. It's the truth. And that's the reality.
It's the truth. Because herbicide cannot be replaced with tillage. Because that's what they did. And you can do it by hand if you've got a market garden, and that's a lot of work, but that's what you could do. But the crimping solution, the strip tillage solution, that is so solid because it's regenerative, and it's also generative, meaning like you can do it again and again, but it also gets better and better. It's generative. It's going to generate change, and it's not sustainable. It's exponential. And and then it's 20 years plus with that same crimper, and that's not going to harm anyone unless, you decide to like run them over with it.
Then you're going to harm people. You're going to crimp them up, I tell you. But the biggest misconception you'd say then, it just doesn't work, which I think that's fair. We run into the same thing continuously.
They all got burned by organic, and everyone was like holier than thou organic. And then it was like the preacher, being like the one with like a prostitution ring. You know what I mean? It's like, whoa. You're the holier than thou person, and this is what's going on. All those traditional guys who stuck around to the traditionals were like, see, I was right. These guys have nutrient, like, they have nutrient deficient foods in organic because they destroyed their soils. My soil looks better. My food is more nutrient dense. And because of that argument, like, organic lost.
Yeah, absolutely. And it still is. And now it's regenerative. Like I said, there's been so many changes, right? It's like organic, regenerative, sustainable. Like, where did you fall into the pot, I guess? But, economic argument now. How do regenerative systems eventually become more profitable, right? And less labor intensive than chemical based systems?
Off the bat. So number one, let's take EM or biofertilizer equivalent, and let's combine it with your nitrogen source. Let's reduce your nitrogen source by 50% this year. Number two, let's get rid of your phosphate or reduce it by a lot. So like, let's say you're on a pivot. Well, you can reserve, until like later in the season, especially if it's the heights are all right with everything, when you're fruiting, to do something with phosphate. So start the season with mycorrhizal fungi in your seed. And then if you're doing your plant sap analysis and it's showing like you're low in phosphate, do a foliar, right? But if not, you're golden. And then the mycorrhizal fungi, like we talked about earlier, if it goes to next year, it's regenerative now, and you no longer pay for phosphate. Especially if you prove it to yourself by just doing the work. You're like, no. I know my plants. This is a sensing meter. This test leads. John will have something else. John Kemp will have his own tester. These things are going to abound in soon. And so this can get rid of your phosphate primarily or all. The nitrates, the nitrogen fixing bacteria that's in EM1 or in any of these other consortiums, that can provide 50 to 80% of the nitrogen. Mycorrhizal fungi can actually provide some of that nitrogen as well. So then if you add microbes to that soil. If it's dead, you add microbes in the drip line for rhizophagy. If they're already in the soil, you don't need to do it. What's the number one thing released in rhizophagy? Nitrogen. So we're like able to like have them inside the plant and then add more. So we could be replacing fertilizer with a Johnson Sioux because we know that those microbes are going to be eaten by those roots and turned into nitrogen. So it's like we really, and then the crazy thing about this is these things are fixing nitrogen from the air inside the plant. You start these microbes early enough in the plant, they're feeding off the sugars from the plant to stay alive. And they're also proliferating. So you add a little bit and they grow along with the plant and then spread through the plant and protect the plant. And so it's really timing. It's really all these different things that allows us to erase NPK. And many people have done it. Herbicide, you've got crimping, you've got strip tillage. You also have bioherbicide, Firehawk. So that removes the waxy layer on the outside of the plant, so it just dries out. Done. And if you're like, oh, I have a root problem, well, you might need to do some aeration and have Firehawk. Firehawk doesn't hurt the soil. So you might have aeration or even flipping things and then hitting that, solarizing that if you have like a perennial root problem. And I know that sounds very extreme. You're like, that's going to oxidize it. Yeah. But that's because you went so fungal. And Rick Clark has this problem. He went so fungal that he's got trees growing in his fields. And you got some options, right? It's like, well, you could be aerating. You could, and where it gets too acidic, you know, and too reduced, yeah, aerate. Not against that. But then also you could be doing hydroxide producers like amaranth as a cover crop. They literally pump hydroxide into the soil, and it reverses that process. And so it literally kills the fungi back, you know? And so it's about finding that Goldilocks range. It's about understanding these things that are free modalities and testing so consistently that you're like, we're starting to shift. And you're also seeing in the field where I'm seeing more perennial weeds and trees growing.
Need to do X, then I need to do X, Y, Z. Let's shift.
Right. And that sensitivity allows you to shift. But I mean, you know, bless his heart, Rick Clark, one of my great friends, it's like he's for all of us, the canary in the coal mine in this regard, because he stepped forward and he's the pioneer. So he's going to experience all the problems and he's going to face all the problems first. And he's going to be the exemplar in all these things first. So you know, I don't bring that up to just like point out what can go wrong, but also to, you know, point out when you're doing this, if you don't have the modalities for testing in a sensitive way, if you don't have the greater understanding of regenerative soil cycles, you could go too far. Because all of us are like, we're alkaline, let's go acidic. We're acidic, let's go. Like it's all a directional. And then very few people are like, I'm in the Goldilocks zone, let's maintain it. Very, very few people are there yet. And so it becomes a different game at that point. But we can increase your soil organic matter, which is going to raise your CEC, which is going to, every 1% increase in organic matter is associated with up to 20,000 gallons of plant available water in the top 12 inches per acre. So you're going to actually, let me tell you the story about Kurt. I'm going to be adding this into this week. So I have this student of mine who's doing Johnson Sioux, and they do flats. And so they do their soil, they do this other compost, they do Johnson Sioux, and all these flats with the seedlings mixed with the soil. So the Johnson Sioux is mixed to the level that the soil will be. And the Johnson Sioux palette always gets algae on top, and it's always wet. And they're like, is that okay? And I'm like, did you know that algae is an endophyte? And they were like, really? I'm like, yes. And then they said, did you know in our field, the pivot, we only can do Johnson Sioux on a quarter of it. And it's always wet. And I have to wait for the rest of the fields to dry out too far to actually water again. And they're in Utah getting 6 inches of rain a year. This is a huge deal. So he's figured out, and he was asking me, is this a problem? And I was like, no, you just made a discovery that is literally going to save you money. You got to do enough Johnson Su now to do the rest of the pivot, because then you save money and you're not like drawing that out too much, you know what I mean? Or overwetting this. And just tactically, you got to do that. But that is so critically important, because farmers with Johnson Su, farmers with a microscope, all these things are tools in your toolkit, and they have to be self-evident. So this is what Rick Clark always says, Ray Archuleta always says, it's like, do it on an acre, do it on a small area, prove it to yourself, then invest, and then scale up. Because it's like, when you get that proof, that confirmation, there's something there that no one else can give you. No words can be said. No YouTube
Nothing.
video, it's
Nothing.
gonna cut through it like you
Getting your
doing
hands
it.
dirty. Perfect. I'm going to go ahead and we'll close it up now. Just a quick rapid fire round. We about ran this thing out of time today, buddy. But here we go. Favorite cover crop?
Cowpeas, because it's in the summer and most people don't realize that they could have a summer cover crop, and that is often the best because they create the most biomass and the most change. Now, I'm not saying do like legumes alone, because that can upset your C to N ratio, especially if you have low organic matter levels. It can just ruin everything, cause compaction and gas off things. But cowpeas, it's low phytic acid. I'm always like, if the world ends, I've got cowpeas. We can eat the greens. We can eat the seeds. Yeah, we will survive. So I love cowpeas, and they're also they're just something that people don't know about. And so I always like bringing that. I mean, everyone hears like, field peas and like fava beans and, vetch and all those kinds of things, or all the grasses, the rye and all those. Everyone hears about those. But
all right, cowpeas. There you have it.
Gotta love
most underrated soil microbe. There's a lot of them, buddy.
I think the most underrated soil microbe is Streptomyces. It's the second most common microbe, and for a long time is categorized as false fungi, but by Elaine. But she was in California, the perspective of she wanted more fungal soils. It was, it makes sense when you look at it from the perspective of where she was bioregionally. But Streptomyces is not a bad guy. Streptomyces is an endophyte that is one of the most common endophytes in the world, if not the second most common. And so Streptomyces is all over. Its majority of the antibiotics are coming from Streptomyces. This is your mycin, all those, right? So, and it was so crazy is people are like, why are the antibiotics becoming like defunct? It's like, because they patented that version of it, and it's an 80s or 90s version of Streptomyces, and every year it's new. Every day it's new. And so these microbes operate on a completely different paradigm. And so Streptomyces being present was associated with bad soil conditions in California, because it was associated with that like petrichor smell and that soil smell that was associated with oxidized and alkaline soil. And it's in pH like 5 soils too. It's like blaming it as if it's fault, but it's there as a caretaker taking over for fungi in those soil conditions. It steps back and goes into appropriate range and roles when there's other things there, but it's still dominant. So I think Streptomyces is one that often gets mischaracterized.
I like it. There you go. Most underrated. What is the one book everyone should read other than your own? Of course, your own, right? Like, I couldn't just be like, what are you thinking?
Well, yeah. I mean, Regenerative Soil is a combination of hundreds and hundreds and hundreds and hundreds of books. But one book. That's such an interesting question. And then what level are we talking about?
Just one book, buddy. You give it to me. You give me the high level, the low level, the mid level. What book you got?
All right, I'm going to give you a solid high level book, Mineral Nutrition and Plant
perfect.
Disease.
By who?
Datnoff, Elmer, and Huber is the one I used, but there's a new edition of that where Huber's not part of it. But
perfect.
It's Mineral Nutrition and Plant Disease.
Nutrition. All right. Mineral Nutrition and Plant Disease. Sounds good.
That's
perfect.
But that's you know, it's very.
That's all right. Nerdy. Some people like it. Some people read the first page and close it, buddy. You know, that's life.
Yeah. Well, just be warned. You know, it has chapter end notes for every chapter.
All right. So you're saying it's a college book? I got you. Perfect. No.
Oh, yeah. I mean, this is the reality. I print out every study that I get that goes into my things. I collect, all these books. I have spore, keys. I have the systematic bacteriology, Berges, which is the highest level of bacterial study in the world and has been for over 150 years. So I just have a lot of things here. I mean, the rhizosphere. This
I know it just depends on where you want to start reading, huh?
Yeah, that's a hard question. I mean, I estimated one day I started counting the books in my bedroom as a child, and in 5th grade I'd already read 3,000 books. And so I mean, I read Lord of the Flies in 3rd grade, gave myself nightmares. Piggy. In 4th grade I read Jurassic Park, and then the Velociraptor ate the baby. So I gave myself nightmares at a very young age, reading books that were probably not appropriate, but I love reading. I was an English major, Brit Lit major, Irish Studies minor.
Perfect. So you love it, man.
And my Shakespeare was my colloquium because I couldn't get into James Joyce.
There you go. So, I tell you, hey,
I am a nerd when it comes to reading.
That's all right. That's all right, man. That's all right. If you would, let our audience know where they can find you, Matt.
So if you type Matt Powers into Google on the first page, and you'll find me. But if you want to go to my website, regenerativesoilscience.com or regenerativesoilmicroscopy.com.
Perfect. Yeah, no. And I just want to thank you so much again, just for today, just for the knowledge that you put out to the audience. I just really hope that at the end of the day that people can glean from this and that it'll be out there going across the world, teaching people and changing the world, and that's what it takes. Really, that's our goal here at Rocky Mountain BioAg, is to change the world for eternity. And that's forever, man.
I love it.
And so at the end of the day, if we can talk to the people and the brightest minds out there to just slowly do our part to push this whole thing forward as we move on into the future, that's what we're looking for. So to all of our audience, if you would, like our YouTube, subscribe, or like this video, subscribe to the channel, share it with your friends, get Matt out there, get all of the, we might even put some bloopers in this one. I don't know. We'll see, where it just cuts out. I don't know. But anyways, we just definitely want to thank you guys all for tuning in, for watching this. Thank you, Matt, again.
Awesome. Thank you so much, Brandon.